Right. Just pay attention to that monitor right now. It's really quick, 5 minutes. Just talk about the changes to the tasks. If you open up the tutorial and scroll down to the bottom, you can see I made some changes during the weekend. So first, we're going to make a PCB out of it, because if you put everything on the breadboard, you can never show it like a product. It's still incomplete. I still need someone in the future to do all the rest of the things. So it's better to just get a product of it, and you guys can practice on PCB design and also the power supply design. Okay, and I give you example. I think we're still not showing. Like this. So I ordered a lot of clips. It's on the way right now. I think like these ones or these ones. I don't know which one will be better. I don't have the experience of it. I haven't done that yet in the past. So you got a clip, and you need to design a little 3D printed container that I can make it something similar to this. I ordered this one actually as an example for you guys, so you can look at it and see how these are designed. You can see super cheap, only $11. But eventually it should be, this will be a product for teenagers. So I joined the Purdue University program, and we actually have weekly meetings from now to mid-March. I meet with them every Friday. And last week we talked about the artistic component of this class, of this project, and why they want to incorporate art in this project. Because a lot of times you can think about that, if something is beautiful or interesting, it's going to seal in your mind for a long time, so you can remember it for a long, long time, especially for these teenagers. You want to make it interesting so they can get attracted to this project. So you can design a little alligator hat. You can see, we have heard about that, right? So these clips are called alligator clips. See? And the first time you heard this is called alligator clip, you memorize it, you remember it. Cannot forget it. So this is magic of, it's not art, but it can be art, can be like bio-inspired design. So that's why we have to integrate bio-inspired design, which is we have a lot of bio here. It's already detecting biomedical signals, and we just need some artistic component in there. So make sure you 3D print it and wrap it up. So you guys are working on this OLED LED display, and see how you can, you can glue it onto the 3D printed containers with all your PCB. So after you design your PCB, you can measure it in Eagle PCB. You know the dimensions, and then you send it out. The PCB for fabrication, it takes like 10 days. So during that time, you can focus on the industrial design of the product, of the container. So eventually, you can own it. I'm not taking this away from you. You just you design it, make it. It's a product. You just keep it. Okay, this is a little thing that you can put on a resume. So in all your skills, after this class, you can check a lot of boxes. Eagle PCB, embedded system, microcontrollers, right? We are going to learn a lot of different types of microcontroller, like ESP32 and ST32s, and you can mention all these on a resume. And for the project experience, you can have one paragraph just talking about this Oximeter product. It's from you have nothing right now, right? You have nothing, but you are starting from scratch, and eventually get a product. I think you should be proud of it. It's very simple. I didn't teach you anything about the code. We just copy and paste. But this is just the beginning of the semester. We're going to, trying to tackle the challenges of the programming in the future, to practice programming, but not this project. It's still too early, and we need this to be done in mid-March. So, okay, so the task. So this is section 4. Section 3, and so the changes, I didn't change anything in task 1. It's still the same deadline. It's Wednesday this week by 8 a.m. I think most of you have already completed based on the experience from last week. On Wednesday, I guess you already finished this. And I think you guys are working on this right now, which is also due Wednesday this week. I think the code and connection is just available down their tutorial, in their tutorial. Hopefully. How many of you have done this, have completed? No? Still?
Yeah, I did the other LCDs. So.
What do you mean? So the big one?
Yeah.
Oh.
But I can't do the wave on it. So.
Oh. The wave is next week, right? It's next Monday next week to show some little spikes. And then I think I changed the deadline for these parts, the plan for the workshop. And also you need a list of those components who are not making the PCB of the module, keep in mind. If you look at the module, it has all these surface mount pads on the two edges. So which means you can design the PCB and solder it onto the PCB. Are similar to these ones. I haven't seen this before, but I will show you. I have done that in the past. These ones. So see, these are microcontrollers, right? These are just modules, and you don't have to design the microcontroller, the PCB inside of it, but it has the pads on the two edges. So you just need to design the pads on the PCB and to directly solder the module on it. Okay, this is not like this is too academia, like not practical. So we are not making our PCBs. That's not true. Because if you open up the big PCB, the motherboards of the lot of systems, you can see they have their power modules directly soldered on the PCB instead of designing every single component of the PCB. It's reasonable because a lot of times the power modules are a little bit tricky to route. They have to have a lot of considerations, the distance and everything. They just don't want to do it anymore. They directly just put in the power module and buy the power module and solder it onto their PCB, which is a very legit way to do this design. It's okay. So we are not buying these PCBs, which will make things a lot easier. And so what else do you need on the PCB? You got a module. You just look at your the schematic here, right? This is all the things we need for the little clip. And you don't need to design the PCB for this display as well. This will be just be screwed in onto the PCB somewhere. And if you keep this at the bottom of the clip, because you need a sensor here so a finger can put on it, right? You can either have everything at the bottom, or you have another piece of PCB on the top. I don't recommend it. I think if you wire things up to the top, will be a problem in the future because you open and close it really frequently. Probably can damage things, make it loose for the connections. But we'll see. I mean, since I just ordered one clip, the one of the Oximeter, so you can take a look at it, see if they have. I think they don't have one PCB, I think, and it should be on either on the top or bottom. But one of the two sides should have a battery cartridge, so have to take that in consideration as well. It doesn't have to be that compact. This is probably your first product in your life. Want to sell some things to other people. You will collect a lot of experience from this project. Also, you can search online, like open source or DIY oximeters, or 3D printed oximeter, things like that. See if you can get some hint by other people's project. Let's see what we need. We need this one, right? You cannot reduce the size of it because this is already a module you want to directly solder on the PCB. You cannot reduce the size of this one. So you need a PCB that you can plug, you can solder this on the PCB and also plug in this to the PCB as well. What about this controller? That's right. Do you want to just use this board? You can, but I do not recommend it. You don't have much space in that clip, and this takes a lot of space and has a lot of redundant components like the USB cable. We're not using this one. We will design the PCB that has. I'll tell you, you can download the Eagle model component, the device for this 330A AU. And I think I have you have done that before, right?
I've seen
What's
it.
that?
I have full Arduino boards even on some Eagle.
Yeah, I know, yeah. And I can download the, I think probably Eagle has a device of this guy. You don't have to draw every single pin of it. You just directly use it. And only two things that you need to power this up is a 5 volts power supply, the regulated voltage that you design in your power module. Same thing. And so you will need that 1 amp regulator. Why do I know you just need a 1 amp regulator? This one doesn't consume too much power, including this guy. It's not a wireless module. It's okay, 1 amp should be enough. So let's just use a 1 amp regulator that you designed, and this guy just need a 5 volts plus a little oscillator. So this I have a lot in the drawer, and that's it. You just need an oscillator plus a 5 volts power supply. It's going to start running. It's going to take out all the instructions from memory and run the microcontroller. But since you don't have a board or USB port on our PCB, so what I did, I had a design. I'm going to show you real quick. If I can pass it. So here's a this is a monitor, right? More that I can do this. So you'll see where is that microcontroller, right? Tell me if you'll see it. Tell me where is that microcontroller? I have a lot. Okay. Where is that microcontroller?
That square shape right there.
Yeah. That's right, yours? What is that? Yeah, yours. Yours. Yeah. And did you see that little oscillator? The 3 lines. That's the oscillator. Okay, that's the only 2 things you need to run it. And you need a power supply. I think I see that. Could you tell me? Oh, I don't have the 1 amp regulator, right? So did you see the big one? Did you see the 3 amp power module? You just did it in your first homework, right? Where is that 3 amp power module? Where is it?
Piece right there. Little 3-prong.
No, the one with the huge ground pad, just on the left-hand side of the microphone. No, that's a transformer. You didn't see it? See, this one. That's one chip. So the ground pad is the backside of the regulator chip, and the 5 little pads are at the bottom. This is just one component. You place it onto it and solder the pins and solder the back. Yeah, for the black one, yeah, it's here. This one. Yeah, the reason I need that one is because the oscillator consumes a lot of power, so I need a 3 amp power regulator. right? Okay, so don't need that many things to let your microcontroller run. It's just the power and oscillator. See that? Okay, so if you look at the Arduino, it has on the back of the Arduino board, it has a USB to serial converter, so it has a lot of things that we don't need. We just need the chip and the oscillator and a voltage regulator that supplies power not just to the Arduino, but to everything, to the OLED and also to the board as well, to the little sensor module as well. Okay, and you can put it on the back of the PCB to save space. Some components on the front, on the top, and some on the back, right? And Connor just found out how to do that. It's just the little scroll. You just push it, and then you can flip it. Very simple. You just grab that component and push it, then it turns into the blue colors, which is the bottom metal color. You can flip it to the back. So for one board, like these ones, Arduino Nano. See, why it's called Arduino? As that one. Why it's called Arduino Nano? Because it's small. Okay, and you can see we have chips on the back. You can do it easily just by switching that to the back. Okay, so you can make a really compact device. You can see if your final PCB is a very similar size or footprint like this one, you can easily put in the little container in the clip. Make a product out of it, right? So consider something similar to this. So how do you find out how to run it like this? I think I have tutorials. Let's see. This one. See, I showed all the pinouts in this tutorial. This is another project down the road in this semester, but you can refer to something, I think, like how to run the OLED and how to design the PCB. I didn't show how to design the PCB, unfortunately. But there's another thing you need to know. Keep in mind. So most of these Arduino Nano boards are not bootloaded. So which means you cannot upload code to the Arduino Nano. So the monitor or the bootloader is a little piece of software being uploaded to the microcontroller. So the new ones, they just don't have it. So the user can actually upload that piece of software, which is called the bootloader, into the Arduino Nano, so it is able to communicate, or it's like a monitor. It's waiting for commands from the USB programmer. So it's able to wait. It knows that whenever you upload, it's going to accept all this code. It's like something in the middle, connect your computer with your Arduino chip. We are not digging into the details of the bootloader. We don't have to worry about that. So, but the thing is, we have to upload it to the microcontroller first in order to program it. That's not like the Arduino Uno. They are ready to use whenever you connect to it, and then it is able to accept all the program from the computer. The Arduino Nanos are not, especially for the ones in the drawer. You have to bootload it. I think Connor did a lot of this kind of job in the summer, last summer. And if you have questions, you can probably ask him. But I also have a tutorial here. See, burn the bootloaders to the Nano boards, but you have to use a Arduino Uno to do it. And I think Connor made a lot of PCBs in last summer just to bootload your Arduino Nanos. Have you tested? Probably not. Okay, try it, and if it works, then you can give it to everyone in the class. That's a great contribution. Consider it if you should give you some extra credits on it. It makes things a lot easier because you can see if you bootload it using Arduino Uno, there are just a lot of issues. You don't have the experience to do it. But if you use design Connor did last summer, you just need to plug it in, and it should be very simple. Okay, let's use and test it. Hopefully that works. Okay. Okay, this is the tutorial on the web page, but it's here. It's the work here. Just keep in mind. Oh, not this one. Anything else that I need to tell you guys? So the PCB design is due next Friday. No, not next Friday. It is next Friday. So I got pretty much 2 weeks, almost 2 weeks from now. 11 days, not 2 weeks, but close. Okay. And after that week, so the PCB files are completed, and we'll send it out for fabrication on Friday, next Friday. And then we got a time to work on other tutorials. We are not just waiting, right? There are a lot of other things we need to cover in the semester, like the PID controls and the little robot car and the temperature sensor network, which is a really interesting project as well. However, but during that time, you still have another task, which is task 5. It's going to be the 3D printing. I'm not giving you 10 days to do that 3D printing. Okay? So it's just something like you work after outside of the class. I got 3D printers in 670. I will give you access to it. And also I will find someone to teach you how to use it if you haven't done that before. So you'll learn a lot of things in this project, including 3D printing, PCB design, and product design, and art. Not really, but it's art for kids. Is that clear?
Yeah.
For the goals for this? Okay. Any questions? You're good? Nice. Okay, so I'll give the rest of the time to you guys to work on whatever you need to work on. Okay.